Okay, hi everyone. Again, welcome to week 6 and welcome to hand general meeting number 5. So let's start with some announcements. So first of all, we have an upcoming hand social. If you haven't seen already, you can vote in Slack on which times work best for you. Right now, I think what's in the lead is Sunday of week 8. So if that works for you, great. If not, vote for another thing. My second announcement is our hand member spotlight. So this is an Instagram series by our lovely public relations committee, and they've titled it A Day in the Hands of. So it's going to be like a takeover series that you get to use on our Instagram account. And to sign up for that, you can use the form that is also found in Slack. And lastly, some other tidbits. You can join our resources channel on Slack. We get a lot of promotions and volunteering events, panel events for members to participate in or volunteer in. So feel free to join that if you're looking for, other opportunities. And lastly, look forward to Outreach's GM takeover next week. Should be pretty exciting. Okay, and that's all the reminders for today. So let's jump into the presentation.
Yeah, so before we start our presentation, we wanted to ask a quick icebreaker. So if you could only keep one of your senses, so touch, taste, vision, hearing, and smell, which sense would you keep and why? And feel free to talk out loud or drop it in the chat. All right, I'm seeing a couple sights. Ooh, we got one taste because Neha said she loves food. Ooh, a lot of sight. Interesting, interesting. You had a touch in there. Does anyone who said sight want to explain why they think sight is the best one? I also have really bad vision, so I feel like sight isn't going to help me. So
I'm interested in Neha's taste because she loves food. I don't know if you guys been to the restaurants where it's like complete darkness and then you just taste food without knowing what it looks like. Oh, Max, go ahead.
Yeah, so I guess to answer Artie's question, I'd probably go with sight just because I want to see where I'm going, and I especially love exploring. So getting look at nature as well as looking at the food that I'm eating, and I feel like I don't necessarily need taste because then I can eat whatever I want without having to worry about whether it tastes bad. For instance, I hate eggplant, so I could start eating eggplant. But yeah, that's my reasoning.
I know Lauren said he just feels like a lot of the day-to-day tasks would be a lot more difficult without sight. And Ellen was saying that sight can take over the other missing senses. So yeah, definitely sight. I think also just in humans, we definitely use our vision more than other animals because let's be honest, our taste and our smell are kind of not as great. So that is really, that's really interesting. Thanks guys. I'd probably say 90% of people chose sight, but if there's anyone else that wants to say why they don't want to choose sight or if they have a different opinion, love to hear it. Anyone have another sense they want to argue for? Now there's an eggplant debate. That's exciting. Yeah, anyone want to only keep their hearing? Oh, looks like sight wins out. So yeah, thanks guys for participating in our icebreaker. Clearly shows we're a very visual team. That's really exciting. And yeah, we're gonna discuss more about the other sensory systems and what the mechanics are for each of them. So next slide.
Yeah, so speaking of sight, we're going to start off with our most popular, which is vision. And so we're going to start with the anatomy of the eye in general, since of course, you see everything through your eye. And so it's very important to just, have a general overview of how this works. And so there are several parts of the eye, and we're just going to go over some basic ones. So you have the cornea, which is like the outer covering that kind of transmits and focuses light into the eye. You have your pupil, which is that hole in the middle of your eye, which essentially changes size to adjust for the amount of light that is available that actually goes into your eye. And so depending on the amount of light that there is, and we can either like dilate to let more light in or constrict to let less light in. You also have the iris, which is what gives your eye its color. And so essentially what the iris does is it allows for the opening and closing of the pupil. And the next, behind the pupil, you have your lens. And so the lens is the transparent item that basically allows you to focus the light right onto the back of your eye, into your retina, so that you can see things clearly. And so your lens will also change shape depending on if you're trying to focus on something that's far away or something that's really close up. Behind your lens, you have just this big chamber or this vitreous body, which essentially just gives the support and like the fluid filled cavity of the inside of your eye. And then finally, at the back of your eye, you have your retina, which essentially senses the light and creates electrical impulses, which are eventually sent to the brain. And so this is where all your photoreceptors are housed. And so this actually allows you to see the light that's coming into your eye. And then finally, that information is transmitted to the optic nerve, which is a bundle of nerve fibers, more than 1 million actually, that carry visual messages from the retina to the brain and allow for us to see what we do see. And so next slide. So now we're just going to talk about more of the inner workings of how your retina is actually able to produce these signals. And so essentially in your retina, you have 2 types of photoreceptor cells. These are known as rods and cones. And so just some distinctions between rods and cones. Rods are generally what allow you to see light, like black and white. They also help a lot with peripheral vision, as well as just detecting general shape and motion of items that are in your surroundings. Whereas the cones are more specialized in terms of seeing color, which of course, obviously can be very helpful in kind of perceiving the beauty of the world, as well as just having more detailed focus on images as compared to the rods. And so in the retina, these, yes, 7C, these cells will actually communicate with more cells that are also present in the retina before transmitting their signal to the optic nerve. And so essentially after your rods and cones, they will actually synapse onto these bipolar cells, which then will actually synapse onto the ganglion cells. And so this kind of pathway allows for the transmission of this information of whether or not there's something that has light that's being shown or not. And so the main electrical way this happens is that when without light, in the presence of darkness, your photoreceptors actually will send inhibitory signals to the bipolar cells. And so this will actually stop the bipolar cells from sending neurotransmitters to the ganglion cell. And so because the ganglion cell doesn't receive a signal, then your optic nerve isn't going to fire and you won't see anything. Whereas when there is light that's being detected, the light will actually cause a conformational change within the photoreceptor cell that allows for the activation of the bipolar cell. And so then the bipolar cell can depolarize, and then this will send a signal through to the ganglion cell, and then this can send an action potential and send this electrical signal to the optic nerve and then eventually through the brain. So this is kind of just the overall electrical pathway that allows for the sight at the back of your eye. So moving on to the next slide, we can actually see how this goes from your retina and then actually goes to be processed within your brain. And so as you can see on the figure on the right, you see that the images actually land on different parts of the retina, and depending on where they land, it will transmit to whichever side of the brain it corresponds to that. And so if you look at each of the eyes, you will see that the middle portions actually cross over. And so you'll see that for example, on the left eye, you'll see the red portion, which corresponds to the left visual field. That red track, that red nerve actually crosses over at the optic chiasm, and so it will be processed within your right occipital lobe. Whereas for something from your right visual field, that can cross over and then be processed in your left occipital lobe. And so that's just an interesting thing to note, is that there is this crossing over at the chiasm that occurs. But yeah, eventually your optic nerve sends your visual signals into your brain, and it first actually goes to the lateral geniculate nucleus of the thalamus, which is able to relay this information to your primary visual cortex in your occipital lobe. And then finally, within the lobe itself, these visual signals are fed into separate processing systems, and so certain like cell layers might look more for shape versus color or movement / location. And so within your cortex itself, there's also different cell layers that are specialized to sense different things about vision. But yeah, that's just a general overview of how you're able to see everything in the world.
And then the next sense that we have is sense, which is actually one of the oldest senses that we have, along with taste and sight. And basically in smell, you have these odorants or these airborne molecules in the air that activate the sense of smell, and they enter your body through your nose and your mouth. And they attach to olfactory receptors, which are located towards like the back of your throat. And these olfactory receptors are actually neurons. So one end of these neurons are attached to they communicate with the external environment, whereas the other end communicates with the brain. So these odorants attach to these receptors, and they generate a tiny electrical impulse, and that impulse is then sent to the olfactory bulb. And then from there, it's processed, sorted out, and then sent to the olfactory cortex, which is higher up in the brain. And that's where you have more deeper processing, and that's where your brain is able to distinguish what kind of smell it is. And our olfactory cortex is actually able to distinguish among over 1 trillion smells, which is really surprising because you wouldn't really think there's that many smells. But there are like even tiny like little differences in smells. And the olfactory bulb is also located right by the limbic system, which is the emotional center of our brain. So that's why like when you smell like certain types of smells that may be associated with a certain memory, or you might like feel nostalgia, because like the two parts of the brain are so connected to each other.
Awesome, thanks Neha. And now we're going to discuss the auditory system. And even though I know a lot of people probably not the biggest fans of the auditory system, it is pretty complex and there's a lot of stuff going on. So firstly, the anatomy. There's the pinna, which is the outside part of the ear, and the external auditory canal connects the outer ear to the inner ear. So there's like 3 major ear portions. There's an outer ear, an inner ear, and a middle ear. And the eardrum or tympanic membrane divides the external ear from the middle ear. The ossicles are 3 bones that transmit sound waves to the inner ear. So they basically are the ones that are going to take the vibrations and basically make them mean something. The Eustachian tube helps equalize pressure in middle ear. So this is why we kind of associate the auditory system doesn't just help with hearing, but it also helps with balance and things like that. So if, for example, you have a really bad like kind of injury to like the side of your head, that could potentially affect your vestibulocochlear nerve and affect your sense of balance. So it's a really important system for that as well. The cochlea contains nerves for hearing. So that is what will send information to the brain, and the vestibule and semicircular canals contain receptors for balance, again, connected to that Eustachian tube. Next slide. Yep, and the hair cells are really, really important in determining what the sound is and helping individuals or helping us differentiate between different sounds. So the inner hair cells are responsible for converting sound waves to neuronal signals. And basically how that happens is that it's through mechanical transduction, which basically means that they need to move in order for a signal to be conducted. So for the auditory system, it's through vibrations. So the cilia, which are basically kind of just hair-like structures are surrounded by potassium ions. And the tip links help open channels so that the potassium cations can flow in. And so as you can see in the picture, they're kind of the red dots are the potassium ions, and the links are what's connecting them, or connecting the hair cells. And the hair cells are polarized when the channels are closed, and cilia bend towards the tallest. And so when there's vibrations, the cilia will bend towards the tallest. So in the picture, they will bend right, and the channels will open. And this will allow all the potassium ions to flow in, which depolarizes the cell. And in this case, depolarization just means it makes the cell more positive, which is a good thing. And so when the cell becomes more positive, it is more likely to send a signal. So it'll send the signal along the axon. And once it hits the end of the neuron, so the synaptic cleft, the calcium channels will open. And as the calcium channels open, that increases the positivity inside of the neuron. And then that will basically trigger all of the vesicles to release neurotransmitters. And then that will send all those neuronal signals about what sound is present, what frequency it is, and where it's coming from. So going on to the next slide, phase locking and then auditory nerve. So just like we had the nerve in the visual system, the auditory nerve is responsible for transmitting auditory information from the cochlea to the brain. So basically telling you again what the sound is, where it's coming from. Phase locking is the ability of a neuron to synchronize with sound. So it will basically just monitor what's going on in your surroundings. And when phase locking occurs, a neural action potential may occur, but they will not occur in every cycle. It's basically kind of for more longer term sounds. And it basically helps with localizing a sound in one's environment. So basically telling, if it's closer to your right ear compared to your left ear, and determining the differences so that you can tell how far it is or how close it is to you. And it tends to occur in a phase with the stimulus. And in the auditory nerve, fibers phase lock to frequencies below 4 to 5 hertz. Yeah, and that's the auditory system. And then Aniket, are you here? I'll take the slide. So basically, taste is kind of like smell, in the case that it requires like chemoreceptors, and it is related to it's not vibrational, it's more related to chemicals in the environment. And so your tongue is covered with papillae, and that's basically your taste buds. And so they're within them, and there's about 50 to 150 receptor cells. And these microvilli will extend from those cells. So if you think about, like, for example, your intestine, the microvilli, you have some in your intestine, very similar to the ones you have on your tongue, and they basically just increase surface area so you can get more information from the stuff that's going on in your environment. And the microvilli will directly interact with the taste sense, and that's where the system starts. So next slide. So yeah, so tastings are basically chemicals that are in our foods or just what we're surrounded by. And so they will depolarize certain receptor cells on your tongue, and that will stimulate the sensory neurons up to the cranial nerves. And the neurons will terminate in the medulla, which is the bottom third of your brainstem. Yeah, the bottom third of your brainstem. And so going from your brainstem, it will go all the way up to the thalamus and into the gustatory cortex. And gustatory just means taste. And that's just where everything basically goes from what you're tasting to what that taste means. So the medulla connects the brain to your spinal cord. The thalamus relays motor and sensory signals. So basically every signal in your brain will probably go through the thalamus at one point before it turns into something that you can actually understand. And the gustatory cortex is ultimately responsible for the perception of taste and flavor.
So our sense of touch is operated by the somatosensory system, which is basically just a lovely collection of nerve endings and touch receptors. And before we talk about the different receptors involved with touch, we need we need to understand how the receptors respond to stimuli. And basically, a receptor can either be rapidly adapting, so it can respond to a change in stimulus very quickly, or slowly adapting, which responds to a change in stimulus slowly. Both types are pretty important, with the former being really good at sensing exactly when the skin starts touching an object, and the latter is able to sense the continuous pressure of an object, and therefore doesn't need the speed to respond to that change. And receptors can also have a varying size of receptive fields. So keep in mind of that when we go over the first type of receptors, which are mechanoreceptors. These can perceive a physical stimuli, so that would be such as pressure, vibrations, and the first one is Merkel's discs, which allow for fine touch, or basically light pressure. Meissner's corpuscles also sense light touch, which is kind of similar to Merkel's discs, but it more focuses on the texture of what is being touched. And both of these receptors have very sharply defined receptive fields. The last two is Ruffini's ending and Pacinian corpuscles, which acts as a stretch sensors for the skin and vibration sensors for the skin, respectively. Both of these have very large and vague receptive fields. Thermoreceptors are the next type of touch receptors. These, again, either sense hot or cold. The cold receptors actually perceive cold as soon as the skin's surface drops below 95 degrees. They're actually most stimulated when the surface of the skin at 77 Fahrenheit, and it stops stimulation when the surface of the skin drops below 41 degrees. And that's why your hands and feet start to grow numb when they're submerged in really, really cold water. Hot receptors are the same. Their perception of hot starts when the surface of the skin rises above 86 degrees, and they're most stimulated at 113. But beyond this, pain receptors actually take over in order to get the body to understand that they are in pain, and try reducing as much damage to tissue and anything underlying the skin. Nociceptors are these pain receptors, and they're important to encourage the body to get away from harm. And it's really handy, especially it's really just to warn your body in order to stop doing whatever they're doing, because they are damaging their own body. In fact, when you do get injured and their nociceptors do cause a dull pain, in order to encourage you not to use or touch the whatever body part or whatever area in the body is damaged. Proprioceptors are responsible for you being aware of where your body is at any place in time. This is important in motor coordination and posture, because in order to stay balanced, you need to know where your various arms and limbs are. And lastly, the sensation of touch and its pathway to the brain involves basically all of these receptors just connecting to the spinal cord and cranial nerves, and they go up to the thalamus. The reason why it's worth mentioning this is that unlike other senses, which only have one cortical area, one thalamic relay nucleus, only one region in the thalamus to relay whatever information coming from that sense. The somatosensory system actually has 3 thalamic nuclei just to account for so many different types of receptors. And each of these groups of neurons project to a specific region within the somatosensory cortex. So that's pretty interesting. Next slide, please.
Awesome, thanks, Christian. And now we're going to discuss neuroplasticity, which is the brain's ability to modify and change its synaptic connections as we continue to learn and take in information. And so in simple terms, this is the brain's ability to rewire itself, and people will call it brain plasticity or brain malleability. And it's really important because if we, if our brains weren't plastic, we basically would not have the opportunity to prune or basically maintain our brain in a way where we can maximize efficiency and be able to take in new information and get rid of old information that isn't as necessary. So yeah, neuroplasticity is for learning or new experiences, to adjust to new changes in the environment and potentially compensate for injury and disease. So next slide. So if you've ever heard the phrase neurons that fire together, wire together, this is the most basic fundamental principle of neuroplasticity. So basically it's kind of like if you use a muscle a lot more, that muscle will get stronger. Same with your brain, you know, the more you learn biology, the better you'll be at recalling that information, or the more that you throw a baseball, your brain will automatically be able to do that function way better than it would when you were first learning it. So pathways in the brain are formed and reinforced through repetition. Again, the more you do something, the better the connections will get, and they'll be more efficient each time. And so the neural network will help us to learn new things and store and recall information. And also if, you know, for example, you haven't practiced the violin in a really long time, those systems will also start to degrade. So your brain will forget the things that it used to know if that repetition hasn't continued in a while. Next slide. So neuroplasticity in sleep. So yeah, sleep is very important in making sure that our brains are healthy and are staying active. So a lot of neural reorganization and growth happens during sleep. And that's why if you can get 8 hours of sleep, that is recommended, but obviously we're all in college, so not necessarily the thing that is the most practical. But again, I do recommend everyone try to get 7 to 8 hours of sleep. It's really good for you. And changes in neuroplasticity are observed during sleep and sleep deprivation. So there was a study done probably about like in the 80s or the 90s where they sleep deprived a bunch of rats, and they found that after a few weeks, I believe, all the rats died because they just were so sleep deprived that it negatively affected even their survival. So sleep is really important for our brains. And sleep dependent plasticity could be involved in recovery from different neuropsychological conditions such as post-stroke brain damage, Alzheimer's disease, or autism. And basically what happens during sleep is basically your ventricles, which are kind of like the holes in your brain, they'll get bigger, and your CSF will basically go through your brain, clean everything up, and basically take it all the way down so it becomes waste. And you have multiple cycles of sleep. So you have like non-REM, and you have deep sleep, and then you have REM. So each cycle of sleep is really important in doing that maintenance and basically either regrowing or destroying those synapses. And that's why again, sleep is so important, because you need time and for your body to kind of go through all of that, and for your brain to go through all of that. And yeah, so again, just get some sleep, guys. I know we're in like midterm season, but that's the most that I can say. And it will help you when you take your midterms, and it will make sure that you're prepped for everything that you do in the future.
So there is actually a typo on this slide. I should say LTP and LTD. So the LTP and LTD are cellular processes involved in learning and memory. So LTP refers to long-term potentiation, and this is a process where synaptic connections between neurons become stronger with frequent activation, and it is a prevalent mechanism in the hippocampus that helps the formation of new memories and memory storage. And so if long-term potentiation is a process that keeps strengthening synapses, there would have to be a process that decreases its efficiency to prevent the brain from overloading. And this would be the LTD, and it stands for long-term depression. And this mechanism is important for the removal of old memory traces and also executing motor memory. And next slide, please. And for neuroplasticity, when it breaks down, the rate of neuroplasticity decreases as a person ages. The brain has the most plasticity during infancy, because as the infant grows, their brain is also growing and changing. And this also explains why learning a new language is so much easier when you're younger, because your brain is more plastic and has more areas for growth and development. And so as a person ages, their brain's capacity to rewire and reorganize will significantly decrease. And this explains why adults have a more difficult time recovering from brain injuries, such as strokes, compared to children, because their brain is occupying at a lower or degenerating rate of neuroplasticity.
And so neuroplasticity is implicated in a lot of like mental illnesses. So some of those mental illnesses are schizophrenia, bipolar disorder, depression, anxiety, OCD, phobias, which are just like fears, and epilepsy. So anytime where your brain basically can't adapt to its new environment, that can negatively affect the brain's function, because that can lead to just too much information being in the brain and the brain not being able to effectively manage what information is most important. Okay, so now we're going to be putting everyone into breakout rooms. So everyone will be assigned a breakout room, like a sensory system. And so there'll be 5 breakout rooms, and we are going to ask you all to debate why your assigned sense is the best sense. So I know a lot of you guys argued for vision, but let's see if you can argue for why the 4 other systems are just as important as the visual system. And we ask that you talk about, what would happen if you lost it, how that would affect the rest of the body, and potentially any lifestyle changes or physiological adaptations you would need to make if you had to function in that environment. So I think Tiffany is creating the breakout rooms. And yeah, we'll probably put you in for about 5 to 10 minutes, and then we'll come back and we'll have you guys all discuss your sensory system.
Perfect. Archie, do you want to put the debate question in the chat, or is this pretty much just whoever's the best one?
Pretty much whoever's the best one, but I'll put it in the chat so everyone knows.
All right, perfect. Okay, sweet. Okay, here we go with our rooms. Very even divide, 8 people each. All right, welcome back, everyone. So I think the way we can go is we can have each team present for around 2.5 minutes, and then have time for, I guess, a debate, back and forth debate at the end. We'll also be doing a little voting for which team gave the best presentation, or I mean, best argument. Does anyone want to volunteer? Otherwise, I'll just choose a sense. Okay, going once. Okay, let's see. Oh, Max is volunteering for Team Touch.
Yep.
Go ahead.
All right, so I'll just kind of bring up some arguments, and then, excuse me. Sorry, I'll bring up some arguments and then have the rest of the team chime in as well. So we just kind of discuss, like, touch is extremely important because it really helps give a sense, like it really helps you coordinate your actions and give a sense for the type of environment you're in. For instance, like one major thing about touch is the sense of pain. So really making sure that you're not in like a dangerous environment. And if you are, you're able to understand, like, oh, I might be in danger. I might, pain might be inflicted on me. Yeah, additionally, just like taking care of daily tasks, like handling objects, making, like, without touch, it would be extremely difficult to just perform those basic tasks. Yeah, does the rest of my team want to add in anything, like Clara, Anna, Christina, Allison, Francesca, other Anna as well?
Yeah, you hit the main points. It was a lot about like being able to know if your body is like in a safe space, or like if things you're doing are harmful to your body, because level of pain often is showing you how harmful something is. And then also, like, if you don't have a sense of touch, you don't know what pressure you're applying to different objects. So it'd be really easy to handle something too roughly or too softly, and you'd end up dropping a lot of things or like damaging a lot of items. And if you had like a child or a baby that you're carrying, you really got to do that very carefully, and you wouldn't want to drop the baby or like squeeze it too roughly.
Great, thank you, Team Touch. That was great arguments. we can move on to the next team. Let's do team hearing.
So anybody who was on my team, feel free to chime in at any time. But hearing, if you lost your sense of hearing, it would be very, very difficult to communicate. Just around with your environment. A lot of stimuli is often associated with sound, and that's how we how we detect whether or not someone's going to get the jump on us, and that's how we that's a lot of noise involves a lot of the stimulus that comes out from around us, behind us. That's how we make sense of the world that we can't see yet, and therefore anticipate in the future. In instances where fire alarms and alarm clocks would be very important, like waking up in the morning, like that's just one less tool in your arsenal if you lost hearing. So in essence, it's losing your sense of touch would be a detriment to your communication skills, and as well as just being just that aware of your surroundings preemptively. And anybody can chime in as well.
All right, any other comments from team hearing? Great, thanks for being the rep, Christian. We can move on to then touch, hearing. Okay, I'll let team vision go.
All right. Well, I had this voiced upon me at the last minute, so we're going to see how well I do. So quite obviously, everything in society is structured around vision, so it'd be pretty crappy to lose that one sense. Speaking from personal experience, I could not survive if I didn't have TV shows, and I'm fine watching with subtitles. So I think that honestly, vision can supplant a lot of other senses. I'm just using that as an example, of course, but like, because vision is one of the only senses to really synthesize everything else together, like you're able to gather senses of patterns and like nuance. You can't really achieve that same sort of thing with only one of the other senses. Like, I mean, if you're blind, you still need braille for most things, and that requires touch. And I mean, if you're operating only by feeling, that's pretty useless. So it's like vision's the one thing where you're able to gather a lot of information all at once, just from like one sense. Yes, and Sai mentioned this as well. For visible, perception is visual. So that's pretty cool. Aside from that, I mean, there wouldn't be a lot of accommodations that you'd necessarily need, just because like a lot of the threats to your physical well-being that other senses do sort of mitigate could also be mitigated with vision if you're vigilant enough, I guess. So just like getting really good at spotting like the things around you and being self-aware, I think would be honestly the best fix. But if anyone else from my group has anything to add to that, just let me know. But I think that pretty much covers it.
Awesome, thank you, Ben, and thank you, Team Vision. Let's let Team Taste go next.
I can speak on behalf of our team. So one thing that we talked about was how taste is such a thing that if you didn't have it, I feel like you wouldn't be able to connect with people of different cultures. So obviously, like all the other senses that we talked about, right? There's a sense of danger that could be evaded with taste as well. I mean, if you taste something that perhaps tastes acrid or bitter, it maybe could send you like a warning sign that this isn't like the best to eat. But at the same time, we talked about how you may not be able to see someone, you may not be able to hear someone, but if you could taste their food, right, if you understand what they really like, you can get to know a deeper side of that person, and you can really just form a bond that's deeper than even talking. So yeah, if anyone from my group wants to pitch in, go ahead.
Yeah, and then adding on to what Kushi said, taste brings a lot of comfort to like the individual. And we saw this with the COVID pandemic, that as people started losing their sense of taste, it became a like very large like hardship on their part, and it made them feel a lot of discomfort. So taste definitely allows us to connect with other individuals, but food is something, it's a huge connecting factor. So that definitely like adds a large amount of significance to how like food brings everyone together, and it's a part of our identity, which is why, you know, losing it could have such a large impact on someone's mental health.
Wow, solid arguments. Thank you both. And last but not least, we have Team Smell wrapping up the debate.
All right, guys, we got a 4-part argument. So settle down because this is about to go in depth. So first and foremost, our daily life. Imagine not being able to smell food. Imagine not being able to go into the kitchen or the restaurant and just be enveloped in all of these amazing smells, and just, you know, everything comes together. And, you know, as we were, you know, as Taste was saying, you know, taste is important, but you can smell without taste, but you can't taste without smell. You know, if you were to close your nose, or, you know, if you didn't have your sense of smell, taste wouldn't be as exciting. But with smell, there's a flavor, there's additional, you know, there's a lot of stuff going on. So smell is really, really important in, you know, putting everything together and making sure that the way that we, you know, enjoy our lives is, you know, fulfilling, and it's, you know, complete. And also, you know, smell is really important if you like need to tell if something has gone bad. So you're looking in the kitchen or you're looking in your refrigerator, you may not see the fungus, but you're going to smell the fungus. So it's really important, you know, in terms of just knowing what's gone bad, or if something is, you know, not doing very well. You know, the first thing that you'll see is the smell. And it's really important because that's going to keep you safe later on, because, you know, you won't eat the food that's gone bad, or you won't, you know, you won't taste the thing that's like really nasty, and you won't like vomit later or have a stomach ache. So that's really important. Does my team want me to go through the other 3 points, or do they want to take it?
I'll take on mental health. Okay. So Artie already talked a lot about not being able to taste food if you can't smell it. But also, people without smell statistically experience higher rates of depression. And the olfactory system, or smell, is connected primarily to the limbic system, which facilitates our memory and emotions. So when you can't smell, you can't feel as well either. And so because the olfactory system also goes, it's the quickest sense in terms of transmission to the brain. So it actually serves as a really important system in being able to identify like neurodegenerative disorders like early on. So smell disorders, like hyposmia, for example, is a really early sign of Parkinson's disease. And so smell serves as a really important indicator of that. And then I guess if anyone else wants to take the last one.
I can take the last one. Do you guys hear me okay? I don't know, like glitching. Okay, cool. Okay, so our last section here is a life-threatening situation. So just to put things into perspective, if there is, let's say, a gas leak or a fire, oftentimes the first sign, or like this can be very easily identified through smell, because oftentimes the first sign of danger is invisible, but typically since smell is the quickest in terms of transmission of signals to the brain, this can be very important in these dangerous circumstances. One example I can point to is, let's say there's a fire, you know, by the time you see the fire using your vision sense, it might be too late. Whereas if you smell the cause of the fire, that can prevent a very life-threatening circumstance for you. So yeah, that's about all of them.
So what we're saying is smell is the best one, and you know, you could try arguing with it, but there's a lot going on. You know, it's memory. Maybe not, but you know, you can very well try.
I love the chat going on. You're gonna smell a car coming at you. All right, any last thoughts, comments? You can feel free to unmute yourself. Any last supportive points here before we take a grand vote? Not gonna lie, I'm very impressed by the last team's presentation.
Thank you, Tiffany.
Probably shouldn't have 3 officers on that team. Okay, so let's take our vote here. Let's see if I can. I'm gonna stop sharing. Oh, launch the poll. Okay, it's the untitled poll, but here we go. We can start the vote. Okay. Oh, I wish you guys could see. I guess you guys can't see the poll, can you? But right now, well, vision and smell are tied pretty neck to neck. So I think we have 2 more participants. You guys are the deciding vote. So, oh, okay. All right, I think we have a winner. It is team drum roll. Archie can see it. Oh, okay, it's team smell. So, wow, look at us. Everyone, 90% started with vision, and look at us go. 42% of the votes went to smell. Oh, I can share results. There we go.
Let's go team. That's what I'm talking
Look at that. Okay. Shout out to education for this really awesome debate. And I hope you guys have a great week 6. Take care.
Thanks, y'all.